Okay. All right. So we finished up talking about stacks, but at no point, oh, don't need that. Don't need that. At no point did we ever actually, like, we never implemented a stack. All we did was define what a stack is, right? All we did was say, okay, we can push, we can pop, we can peek, we can check if it's empty, we can get its size, okay? So we never defined how a stack does what it does, but we defined what we could do with the stack. The idea here then is, if we come along and want to make a stack, like implement one, and we abide by what a stack is based on this interface, then we have a stack. We're in great shape. Yes. So, oh, and then lastly, we did kind of talk about this generics thing, which is a nice way of basically specifying what type you want in the stack. Because a stack, well, what are the objects you're putting in the stack? Well, integer, strings, friends. It's like a variable for the type, which is pretty cool. And if you did assignment 1, the hash maps have this, right? Except in those you had 2 different, which is cool. Now, another thing. No, I guess that's okay for now. So yeah, any last questions? Also, yeah, you can download this. Show in folder. No, that's the ArrayStack stack. Hold up. If I go here, don't want that. Here, let's just plop that in there. Sure. There, stack. Now I have my stack interface in my collection. Public interface stack. Notice that unlike the others that say public class, this says interface. Here I just describe which each of the methods does. Void, push, t, pop, yt. Well, the pop will return something of type t, whatever it is. T could be an integer, it could be a string. T peek is empty, it's just a Boolean, and size is the integer. That's it. This just defines what. Doesn't say anything about how. Okay. The interface part. Does it always have to be T? Actually, no. You could make it change. Like, you could put whatever you want there, but just T is a convention. I think technically there is a set of rules Java has that no one really follows. Java symbols. So, yeah. So E is for element, K is for key, N is for number, T is for type, V is for value, and then SUV for whatever. So a lot of people would actually say, oh, you should use E because it's an element, because this is a collection. I mean, those are things, but you know what? We're just going to stick with T. Yeah. Okay. So here's our stack. Great. Now, of course, this tells us what we can do with it, but it doesn't tell us how. So let's look at how. Well, how do we go about... oh, here's next. Ooh. Check out the aside on postfix. I'll let you do that. That's homework for you. Next. ArrayStack. Okay. Now, how many ways are there to solve any problem? Like an infinite, right? So we can do whatever the heck we want. So the first thing we're going to do, something that seems natural to us, might be like, well, let's make a stack, but you know, it's based on an array, right? The container, the thing that we're going to use to hold on to the information is an array, because that's what we're used to so far, right? At least 3, that's correct. So an array stack. So we're familiar with what we want the stack to do, but we never said how. So obviously, though, in order to actually use the stack in Java, we need to actually implement it. It won't magically know what we want. We need to actually write the code. So I'm always talking about, wow, we care about the interface. Yeah, but we like to make sure we're separating the interface from the implementation. The what from the how. Very important we keep these ideas separate. It helps us a lot. So we need to think about some implementation issues. 1, how are we going to keep track of the data? And it's a stack, so, I mean, a lot of the action happened at the top of the stack, right? So we need to keep track of the top. And that'll depend on our choice of how we're storing the data. Well, an obvious one to you might be an array, because we already saw how we could use an array to store contiguous data, right? And a number of times in the lab, in the assignment, in the lectures, whatever. Arrays are handy for this. It's perfect. Now, I will give you a heads up. Many of you will probably find stacks far simpler than the contact list or the course list or the country catalog. So FYI, if you hated that, this is actually it's simplifying by removing a lot of functionality. But then in computer science, we love to play with like minimal things and see what we can do with them. Does the stack have to have all the same type? Yes, but no, but yes. Well, I'm going to say yes. There's an asterisk, but we'll stick with yes. All right, so we've already seen that arrays are great for contiguous data. Okay, hold on. With the boops, let's keep the boops minimal to some actual questions. We've already seen the arrays are great for storing contiguous data, like something like this. Now remember, when we have objects in our arrays, the contents of the arrays are actually like references to those objects. So these boxes are representing the objects and the arrows are the references to them. Okay? So let's say we have a stack. We want to implement, nope, not that one. The stack. We want to implement this idea, right? We want to implement this idea with an array. We want to make sure we're holding on to all of the information in the stack. But we need, all of the action in the stack is happening at one end, at the top. So we need a way to keep track of the top. Yeah. So when you look at this, where do you want the top to be? Right? An obvious answer here, is there a way to sort a stack after it's made? To sort it? Yeah, you could, but you'd actually end up taking all the stuff out, sort it, and then re-add it. You don't use a stack for sorting things, typically. Okay, so I see someone suggesting size -1. Well, that's a good one. But let's start to talk about 0. 0 could totally be the top of the stack. We could do that. And the handy thing about having the top of the stack being 0 is we always know where it is. We don't need to worry about okay, well, where's the top? Right? Because, well, it's always 0. There's no need to store information about where the top is. But the problem is, every time we push something, every time we add something, we're going to need to make room. Let's see if I can copy image. And, got to plug in my fancy stylus. If I could find the... There we go. Right, because if I come here and I say, okay, great, and I want to start pushing something, well, the issue now is I need to move everyone down one. Okay, 1, 2, 3, 4, 5, 6. Now I have room and I add the new thing here, right? Great. I mean, it works, but if there's n things in the stack, how many things do I have to move? All n of them, right? And similarly, if I pop something, okay, great, this one gets removed, but then we got to move this one down, then move this one down, and then move this one down, move this down, move this down, just so we make sure that the top of the stack is an index 0. And again, if we have n things there, we're going to have to move all of them. So these are linear time operations if the top of the stack is at 0. We could totally implement the stack this way. It is not incorrect. If we implement it this way, and we code it correctly, if we do this, we will have a stack. It's just that our operation of pushing and popping are going to be linear when there might be an alternative. So it's basically a question. Okay, hold on. Of what's easier, keep track of where the top is versus move everything down by 1. This is seen in part 4 of the assignment. Okay. So what are the pros and cons of making the top the other end? As I think it was T2 suggested, size -1. If the top is always this, if the top is always like this one, size -1, because we'll keep track of the size of the stack, right? Here the size is 6, right? 1, 2, 3, 4, 5, 6. Yeah, perfect. Size is 6. So if this is the top, we need to keep track of the top. Which I guess is like, okay, well, that's like 6 minus 1, so that's 5. So the downside is we need to like make sure we like store that information of where the top is. But the upside is if I want to push something, I just add it. I don't need to move anything. If I want to pop something, I just remove it. I don't have to move anything. So suddenly these things that were linear before when the top was 0, now they're constant time. They're just easy peasy. No, it doesn't matter. There could be a billion things in there. It's still going to be constant time. The size of this stack doesn't affect the amount of time it takes to push and pop. And really, when you think about it, if size, like if the top thing is always 1 less than the size, we don't even need to keep track of the top. We just go like, okay, well, it's just size -1. So there's really no downside here to having it be the end, which is pretty cool. Can't you just store one of them and add 1 or -1 to get the other? I don't understand your question. Oh, I see, with the top and size. Yeah, of course, yes. Okay, okay, the strategy we will use is a variable to keep track of the next available spot in the array, just like we did with the country catalog, just like we did with the contact list, just like we did with the course list, right? Why would the top be 0? Would you ever? If you wanted to implement it where the top was 0, you totally could. I wouldn't, but you could. Yeah, they are, Kaylin, yeah. So push always happens at top, and then pop will be at top -1, because we don't need the extra stuff there. What's the P? So top is size, well, the thing on the top is at index top -1. Whenever we want to push something, we just push it to index top. So here's the idea of our stack. We have some stack object, and this is the this is like the information we're going to want here. We're going to want like a reference variable to an array that's going to hold on to our stuff. And we're going to want a variable to keep track of the top. That's it. That's all we really need. Then if I come along and I want to push something to my stack, so here I'm pushing this like, I don't know, turquoise, dark turquoise box. Well, I go and say, okay, well, top is 4. So we put it in index 4, and then we increment top. Great. And then if we pop, well, okay, that's great. We go to index 5 -1, top -1, which is 4. We set it to null. We return it. And then decrease top. Pop again. Okay, 4, top -1, well, that's 3. And then decrease it to top to 3, and so on. That's all. That's all we got to do. This is a very simple data structure. That doesn't mean it's not useful. In fact, this is remarkably useful. And I really do want to emphasize, I kind of talked about at the end of 161, computer scientists love to have limited things and then seeing what we can do with those limited things. What does the S box on the left for? Oh, that's like if I created my stack object. So I would be like, okay, if this is, we're going to define a stack object. And then if I say like, okay, stack S equals a new stack. That's like that. If you're scratching your head still, once I code this up, it'll make a little bit more sense. All right, great. So let's start implementing our ArrayStack. Okay, so this is how we'll do it. I'm going to go here, right click, new Java class, ArrayStack. Okay, now public class ArrayStack, but one, we want it to be generic. So I'm going to add this fancy T like that. And also you'll notice this implement stack. What this does is it tells Java that the code in here, the code I'm about to write, this class, is going to implement everything in the stack interface. But by having this here, it's not only that like, oh, we're telling Java that we're going to. By saying this, we are required to now. I have to. If I'm making something that implements a stack, I have to come and implement all of these methods. Push, pop, peek, is empty, and size. I have to. If I don't, it's not a stack. What's T again? A generic. Okay, could it be any letter? Yeah, it can be. We just talked about that. Yeah, it can be, but leave it as T. Is a stack a class or a method? A stack is going to be a class. We are defining the stack class. How did you get stack? I wrote that. That's this right here. This is what we wrote in the previous topic 5, right? Public interface stack. If we go back to previous real quick. Okay, come on. Public interface stack. So this is where this comes from. Like we wrote this interface. So now, okay, great. But now we're coming along and we're saying, okay, we're writing an array stack and we're going to implement stack, which means if our array stack implements stack, then we can guarantee that array stack is a stack. Like that, I mean, it sounds like, okay, yeah, no, duh, but no, like if I'm a programmer and I use ArrayStack and I know that it implements stack, there's no ambiguity to me that that class is in fact a stack. It's safe to use because it's a stack. Private, static, int. We'll have a default capacity, but this time we'll make it 100 because why not? Okay, how'd you get stack? No, like how it green. Wait, never mind, I got it. How it green. Oh, here? Oh, it's because it says interface. Because when I made it, new Java class, you can actually select it as interface, but all you have to do is just change class to interface, that's all. And then IntelliJ is like, oh, it's that. Or did you mean this stuff? The comments? Did you mean the comments? No, the interface. Okay, cool. So what's the difference between a class and an interface? Well, the interface is the what? The class is the how. Right? So the interface, look at the code in the interface. There is no, like, push or void push. We are saying, okay, there's a method called push, and what does it do? Pushes adds an element onto the top of the stack. After the method completes, the item added will be the thing at the top of the stack. Parameter element, the item to be pushed to the stack. Right? So this is saying what? But there's no code in here. It doesn't tell Java how to push anything. So the interface is just the what. The class, this is where the code's actually going to be. This is where we actually implement that stuff. It's like comments. I don't know. Why interface? Because this is where we get to say, this is what a stack is. And if any class comes along and implements this stack, we know it's a stack. This is just where we get to define the what. Remember, how many ways are there to implement the stack now? Literally an infinite. So I can make a stack, but what kind of stack is it? Is it an array stack? Is it a different kind of stack? Is it a what stack? The problem is with those infinite number of things, if those infinite number of ways to implement it all implement stack, I can then guarantee they are, in fact, stacks. Where if that's not there, I can't guarantee it. If this is leaving you scratching your head, you're pretty normal. But once we get to linked stack, which is the next topic, it'll probably become a lot clearer. So the interface is a layout of what the stack is. Why did you say implements? Why do you say implements like in ArrayStack? Here, well, because now we're saying we're going to implement the stack interface, which now says, like we have to. This code has to implement each of these methods. If it doesn't, it won't work because then it's not a stack. No, you do not. You write the method names, but you don't actually write the code in the interface. And then you actually write the methods in ArrayStack. Yes. Yeah. So you might say like, but why even bother doing that? Just write it like this and make it a stack. Okay, great. But if we have this, and this is what the definition of a stack is, if this thing implements, come on, implements the definition of a stack, now I can guarantee that this is. Where if it's not there, well, what if some hoodlum comes along and writes an array stack, but they didn't write one of the important methods, and next thing you know, you're trying to use it and you're all in big trouble. Again, this will be a little clearer once we talk about linked stack. If it's clear to you already, great. If it's leaving you going like, okay, whatever, just go with me on it. All right. So back to here. Okay. Private T array stack. Okay. So we want an array. Okay. So private array of type what? Well, T, right? We don't know what it is. If we want a stack of integers, well, then we're going to want an integer array. If we have a stack of friend objects, we're going to want an array of friend objects, right? So it's whatever T is. So a T array called, we'll just call it stack. And then private int top. Great. So we have started defining our class, but all we have now are the fields. You'll notice that if you're following along or if you're watching, like IntelliJ is yelling at me saying, class ArrayStack must either be declared abstract or implement abstract methods in abstract method push. And it's actually going to be a lot more than that because we need to implement push, pop, peek, size, and whatever. There's going to be more issues here. But this is basically saying, you're saying you're implementing it, but you're not. So where is your push method? You never wrote the push method here. So that's what it's whining about. It's never used. Public final, private final, static final. I never remember the order that's like preferred, but whatever. Static final, okay. All right. So now let's make a constructor. Public array stack. Here we don't put the T thing. Why? Just because we don't. Oh, okay. Let me actually go through this part first. Okay, we want our array stack to implement the stack interface. This way, anyone using our implementation knows that it is a stack. The array stack is a stack. Anything a stack will be happy getting an array stack. Anything expecting a stack will be happy getting an array stack since it's a stack. Note line 1 where we specifically say implement stack. Yes. Since our array stack is generic, we don't know what the type of the array should be at this stage, so we make the array of type T. Warning. Yes. Okay. Here's me saying. When you start implementing, your IDE is going to yell at you. Yeah, like I just showed you. Okay, constructors. Okay, so let's write a constructor array stack, just a default one. And what we're going to do is say, okay, well, when it starts, we're going to want top equals 0, right? because, well, there's nothing in our stack. To start, the stack starts empty. And now for something I find annoying, a lot of people find annoying, other programming languages do this slightly better, but this code right here. So if you don't like this, it's the magic code. To me, it's kind of like the magic code. Oops, this should be default capacity. What this is saying is, okay, there's a rule. In Java, we can't implement an array of type T. We can, but we can't. You can never, like, we're not allowed to say, like, this equals new T array of size default capacity. Okay? So it's saying, okay, type param T cannot be instantiated correctly. Okay? Oops. So Java doesn't want us to do this for whatever reason. So what we do is we say, okay, we're going to make a new object array. Okay? So we're going to create an array of some objects. And then we're immediately going to say, this syntax right here is for casting. We're immediately going to say, but those objects are type T. If you're like, what? That's dumb. Yeah, I get what you're saying. I totally get what you're saying. I'm going to be honest. Every single time I need to make a new array of generics, I like go re-look this up going like, how do you do this again in Java? So don't be afraid to go back and remember like, oh yeah, okay. When we talk about array stacks, we see how to do it. Make the array generic. I apologize for that on behalf of Java. So that's kind of annoying. And we'll write another constructor that doesn't use that does not use the default capacity. We'll just do this, size 0, except now we'll use whatever the capacity is that we pass to it. Yeah, okay, whatever. Apology accepted. I thank you on behalf of Java. Okay, great. So now we have our two constructors. This is going to look very similar to like a contact list, right? All right, contact list, one, the default capacity, one, whatever capacity we pass to it. Now, I'm going to show you something kind of cool, though. There's something called constructor chaining. One thing we like to avoid is duplicate code. And you will see that this code here and this code here are effectively identical, right? And we don't like that. So what we can do is chain our constructors. We can actually say, okay, this default capacity. What this is saying is, okay, on this, remember that's like this object. This syntax with the this open parentheses is like calling the constructor of this object. If we do it like this, it's going to be like, well, no, that's not happening. You have to do it this way for constructor chaining. But what this is letting us do, this is a neat feature. What this lets us do is like, okay, if anyone calls the constructor ArrayStack, just call the constructor that takes an integer, but pass that constructor whatever the default capacity is. So it's pretty cool. It's just a nice way to kind of eliminate some code writing, right? And then if I want to change how this constructor works, I don't need to change it like in multiple places. I can just leave it alone right here. Or I can leave this alone because all the updates happen in here. It's pretty cool. It's like having a method call another version of itself, one of the overloaded versions. So it's kind of neat. And this is the syntax. Why? Because someone somewhere said this is the syntax. So just call this and pass it this value. So this right here, if I click on it, even if I control click on the this, it'll just take me right to that one because it'll be like, no, it's right here. Check it out. Can't you just say static final default capacity? Well, we have that up here, right? And then I'm passing the default capacity. If they ever call the constructor without specifying a capacity, We just automatically call this constructor that takes a capacity, but with the default capacity. Okay, cool. Okay, great. So now we have our constructors. You might say, what's the point of even having this one? You're right. Maybe we shouldn't. Maybe we should just have the default capacity one, whatever. Just, it's there because it's there. Okay, you'll see where we're doing overloading is constructor chaining, aside constructor chaining. Here's an aside on it if you care about. Just, there's 3 points. You also see that we're creating an array of objects and then casting it to the generic type T. We can't actually instantiate a generic type, asterisk. Java also forbids creating a generic array. The details are far outside the scope of this class, but if you really care, you can read this. When doing this, though, Java will warn us that there is now an unchecked type conversion, which is just basically saying Java can't guarantee that this object array is in fact of type T, but like it's on, like when we're creating it here, we're like it will be, so it's fine. We can actually suppress this warning by throwing this up here. So I can throw this up here, there. And this just tells Java and the IDE, like, just shut up. Okay, I know what I'm doing. Suppress this warning. Otherwise, we put that there. You'll even see that my warning count increases. Unchecked cast, where if I put the suppress, it goes away. This is called an annotation. It's just a fancy little way to add extra pizzazz to our code. You do not need to have this. It's not going to make a difference, but I'll add it because it shuts it up. Okay, so here's what we would have if we wrote something like stack integer s equals a new array stack of size 5. This is what we would get. We have our stack object. We have our stack object that's referenced by the reference variable to a stack called s. That's this bit here. Its top is 0 and its size is 5. Why 5? Well, that's what we put here. Now we need to write push. Okay, so public push, void push, there, push. You'll also see this override. That's basically saying like, yeah, I'm overriding the method push. We don't need that, but it's kind of cool to have it. So I'm now writing the push method. Where did this come from? Right here. This is what this is the one we are writing. We are now writing the push method that the interface said we must have. So how do we do it? Well, to add something to the array, we know that the next available spot, if we go here, top is always the next spot, just like it was with the contact list. So I can just come along and say, okay, well, stack at index top is now equal to element, right? So put that element that we're adding at index top. And then once we're done, well, top plus plus, right? Increment top. There, we're in great shape. But of course, what is the giant gap here? What's the issue with what I've done? I can push how many things before this gets angry? In fact, no, I can't do that yet. Right? So what's the problem with this push? 5. Yeah, 5. 5. I know what you mean when you say 5. I'm going to run out of room. My arrays have fixed size, right? What exactly would pop plus plus do in this case? You mean top plus plus? That means make the variable top, which starts at 0, become 1. Yeah, and we do need time to expand, time to the capacity. Yes, capacity is the issue. Date Mike, is this, where's your fancy hat, Date Mike? That's just incrementing 1 to the variable top, which starts at 0. So if we put the thing at index 0, well, now the top is 1. Although really it's 1, it's top minus 1, but. So is expand capacity an important method to memorize when working with Java arrays? Memorize isn't the right word. The right word would be knowing that you have a fixed size array. So a solution, though, is to make a new one that's double the size. So let's write our private void. You'll also notice that a lot of our expand capacities are going to be the same. So we're going to need to make a new stack. Well, a new stack array. Again, the same issue here with having to cast it. But what I'm going to say here is now, okay, the original stack, stack.length times 2. Oops, my goodness. Fat fingering a lot right now. And of course here, this is a T array new stack, right? So here I'm making the new array that's twice as big as the old one. And it's referenced by the T array reference variable new stack. Then for I is less than top, I plus plus, new stack at index I. So take the new stack. At index I, it starts at 0. So go to the very beginning of new stack and put whatever is in the old stack at index I. So copy over old stack at 0, put it in new stack at 0. Copy over old stack at 1, new stack 1. So copy all of those reference variables over to the new stack. And then once we're done, that field stack that did reference that variable was too small. Well, now reference the new stack. Just you now equal the new stack. Great, done. So here is our, oh, and here we can do our like suppress warnings. Unchecked, great. So now it's not whining at us anymore. So we have our expand capacity. Any questions about expand capacity? I know we've talked about it a bunch of times, but it's very important. So what is unchecked? It's basically me telling Java, IntelliJ to shut up. Because if I don't do this, it's gonna say like, oh, unchecked cast, which is right, but I'm smart enough to know what I'm doing and that what I'm doing is safe. So I just say, just shut up. Suppress that warning. Which warning? The unchecked warning. That's all that is. It is entirely not needed. It's just if I don't have it, you'll see that I have that 5th warning. Any other expand capacity questions though? Is it possible to suppress all warnings? Maybe, I don't know offhand, but I would be very cautious of doing that. All right, seeing no other questions, I'll assume expand capacity is fine. But if it's not, like if you're struggling with expand capacity, make use of the resources, right? Come to office hours. Expand capacity should be some of your favorite code. Come to office hours, watch the videos, look at the lecture notes. It's all there. Practice, practice, practice. Study, 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 right? Because you're all going to be the best computer scientists. Okay, so we need our fancy, expand capacity. And look. The code is actually effectively the same. Oh, but the difference is I said stack.length. But here I put top. But top and stack.length are going to be equal if we've run out of room. So it's okay. It is, thank God. Thank God, Prison Mike. I was certain I had it, but good catch. Because otherwise, I could get the last 8 minutes of class. So now I just say, okay. If it's the case that top is equal to stack.length, meaning we're out of room. If we're out of room, just call expand capacity and then carry on. If this is not the case, well then just ignore it. Just pretend it doesn't exist. But this right here, now we're in great shape. Now we can push forever until our computer runs out of RAM, and then we're happy. We're never going to run out of room in that array. Okay. So there's our push. Okay. Okay, like contactless example, we need to watch the size of our arrays. Okay, pop and peek. Okay, pop and peek. They're going to be very similar. Pop returns the thing at the top and removes it from the stack, where peek returns the thing at the top, but does not remove it. So they're going to be very similar. So let's go down here. pop. Okay, so I'm going to write this slightly different. What I'm going to do is I'm going to say, okay, T to return equals stack at index top minus 1. Okay, because I know that the actual thing, remember, top is the next available spot. Top minus 1 is the thing really at the top. So we've got that. Then I'm going to say stack at index top minus 1. You are now equal to null. So this now references null, but we still have a reference to the thing that we want to return via this reference variable. I'm going to decrease top minus minus, and then return to return. Okay, so there we go. Do that, do that, do that. And let's compare it to the code I provided you with. Ignoring this, which I'll talk about in one moment, you'll notice that it's actually in like reverse. Not reverse, but I do the top minus minus first. But the reason for that is, like, I'm always doing top minus 1, top minus 1. Okay, now decrease top. Well, if we just decrease top first, we don't need that extra minus 1 here. So isn't that handy? And then we just return it. And peak is going to be nearly the same, but way easier actually. All we have to do is just return stack at top minus 1. There. Because we're leaving it there. We just want to return a reference to the thing on the top, but leave it on the stack. Now, we have a peculiar issue. What should we do if someone comes along and tries to pop or peek from a stack that happens to be empty? Right? What do we do? Should we ignore the problem? Should we crash the program? Should we do something else? I don't know. It's hard to say. What should be done is not up to us. We are the ones implementing the stack. Someone else is going to come along and use this stack code. It might be you. It might not be you. But someone else is going to use it. And they might try to pop or peek from an empty stack. So what are they going to want to do about it? I don't know. There's no way I can know. But what I can do is send a signal to the person in the future using my stack. I can send a signal to them saying, something funny happened. Deal with this however you want to. So I throw an exception. This is following something called the principle of least surprise. And if you go here to Wikipedia, the principle of least surprise, it's this idea in software design. But should we expect to get nothing back when requesting the top? No. When we request the top, our expectation should be we get something. Perhaps it's reasonable that the request was actually more invalid. Like, if the expectation is that when I pop, I get something, or peek, I get something back, right? If I don't get something back, we can't just say like, okay, just ignore the request. Because, no, the default assumption is that you get something back. So when I don't get something back, it's more reasonable to assume that that request was actually invalid in the first place, where you can't get something back. So imagine having 2 apples and asking 2 apples for the third apple. The natural response the apple's going to have is like, what? What? That's not, what? So what I'm saying here is we are implementing the stack that can be used by someone else. What should be done then by them will depend on what the code they're using the stack is doing. The point is, I can't possibly know what you want to do tomorrow with my stack implementation I'm writing today. What I can do, however, is send you the signal. I can throw an exception to let the user know something exceptional happened. Then it's up to them to deal with the situation accordingly. It's not up to me. So if they ever come along, if top is 0, throw new no such element exception. How does that work again? I want to make sure I get the syntax right. Yeah, no such element exception. Right? And then I'm going to do the same thing here. Peek. If the size is 0, throw this exception. And whenever your code throws an exception, the method stops, similar to like a return. So if it's ever the case that the person using my stack that I'm writing would be getting nothing back, what are they going to do in that situation? Is that a good thing? Is that a bad thing? I don't know. I'm going to give them the exception. If it's a good thing, whatever, they'll catch the exception and ignore it. If it's a bad thing, they'll handle it however they want to handle it. That's not my problem, though. That's their problem. Think of it like this, too, right? What happens when you try to index the array in an index that doesn't exist, right? Well, when you go and index an array, you expect to get something back. If you go and index something that doesn't exist, and it just doesn't do anything, well, that's not very helpful. What it does is it says, nope, can't do that. It's your problem. Something is funny. Something was unreasonable in the first case. So you got to deal with this. How do you know what kind of exception to throw? Experience. This case here, this one here just makes sense. No such element exception. But there are a lot of exceptions you can just go look up. All right, and unfortunately, that puts us out of time. Warning, to use no such element exception, you'll need to import Java util no such element exception. Yeah, if you go to the top, you'll see that now. Handily, IntelliJ added it for me. So yeah, I guess we'll end here, but we're very close to finishing the stack. All we need is the size and is empty, and that's basically it. Oh, and then we want our toString. But if you can, I'd recommend maybe trying to finish this off on your own and see if you can get that all working. Can you just throw null? Don't do that.